This is going to be the third part of the ongoing topic, that is laws of force and motion. In the previous two parts, we discussed about the definition of force, its formula, its SI unit, and the various interrelated terms. We have also discussed about the balanced force and the unbalanced force. You can check that on the previous two videos. Now, in the previous video, we also discussed about the first law of motion. In the first law of motion, the most important terminology that we have to understand is the inertia. We understand about the inertia. So what is inertia? It is your state of, it's your state basically. So in which state you are, that represents your inertia. So inertia are of the two types. First is rest and the motion. Let us say a mountain. A mountain is staying in its place for a very longer period of time. So we call it as an inertia of rest. And let's say, for example, earth is revolving around the sun. Right? This is a sun and this is your all the planets earth. So earth is continuously revolving around the sun. So we call it as an inertia of motion. Inertia in the sense represent your continuous state in which you are. Right now I am sitting and teaching for 1 hour, so I will call it as an inertia of rest. And if somebody is traveling, we call it as an inertia of motion. Got it? So this was the concept of inertia. Now what does the first law of motion says? It says that an object will remain in its inertia of state or a motion until unless we are not using any kind of external force. Okay, that was all about your first law. First law says that, let's say this is a ball. Okay, now this ball is at rest position, which means that its inertia is of rest. Now until unless I won't kick it, it will not move, right? So the moment I applied my kick is an example of external force. So I applied the external force and now this ball started moving. So we are changing its inertia from inertia of rest to inertia of motion. So that represents your first law of motion. I hope that much is clear. Now our focus today is going to cover the second law and the third law. Got it? So what does the second law of motion says? In the second law of motion, we have to define one terminology, that is your momentum. Now understand one thing very clearly. We have momentum. Momentum represents by the letter P, okay, and its formula is mass into velocity. Got it? And what is force? What is the formula of force? The force formula is mass into acceleration. Right? Now tell me, what do you mean by acceleration? Acceleration is change in velocity. Right? Acceleration is what? When you are changing your velocity, and that change in velocity, it's talking about the force. So that defines the two formulas define the difference between the force and the momentum. What does the force says? Force says that whenever you are having a certain kind of mass, let me just change my ink, that whenever you are having a certain kind of mass and you are changing your velocity, that time in order to change that velocity you need to apply a certain kind of force. So force is what? Force is when the mass is changing its velocity. That is your force. But what is momentum? Momentum is simply that you are having a mass and you are moving. You are just moving in a particular direction. You are not changing your speed. You are not changing anything. You are just moving. You are just moving with a fixed velocity. So that is known as your momentum. Is that clear? For example, the momentum example is very famous example. That is when you are catching a ball. So the moment you catch the ball, your hands move backward. Why your hands move backward? Because the ball contain a certain kind of speed. The ball is coming with a certain kind of speed, and to neutralize the speed, the hands go backward, and when your hands are going backward, they represent the momentum case. See what happened, that in physics so many different laws are happening at the same time. So when we have to define a particular event, we take the particular example and then we try to explain that particular example with the help of the ongoing lecture. So here currently what I will say, that when a ball is coming with a very high speed, so when you are catching the ball, your hands will move backward. When the ball is coming with a very high speed, okay, a normal speed, the ball doesn't have that much speed, so your hands can control it, so you are not making it move backward. But when a ball is coming with a very high speed, your hands will automatically move backward. Why they are moving backward? Because the ball is having a speed, and to control the speed, to neutralize the speed, the hands will move backward, and this is the prime example of momentum. Last thing that I want to make is clear about the momentum is that momentum is nothing, it's the mass in velocity. That's it. Where whatever the mass is, if it's in velocity, if the mass is having a movement, okay, we define it as a momentum. Now there can be n number of examples. A ball is moving, that is also momentum. Earth is moving around the sun, that is also momentum. A train is moving, that is also momentum. Okay, so everything that is in a velocity and that have the mass, we call it that represent momentum. I hope that much is clear. Again, I will explain this thing to make it clear, and now this is going to be my final statement. Okay, so make it clear right now. One second. So what is force? Force is when your mass is changing its speed. When your mass is changing its speed, we call it as an force. But when your mass is moving with the constant speed, or your mass is having a speed, we call it as a momentum. That much is clear. Now understand this. What does the second law of motion says? The second law of motion says that the rate of change of momentum, the rate of change of momentum is directly proportional to the force. This is the statement of second law. What does the law says? The rate of change, the momentum is changing now, is known as the force. Yes, that's what we have learned so far. What we have learned, that whenever your acceleration or your speed is changing, that is known as force. And now the same statement we are saying in the second law also, that whenever your momentum is changing, which means your velocity is changing. What I told you, mass is a universal constant, so it will not change. If you are 60 kg, you will be 60 kg. So but your velocity can change, you can either run fastly or you can run slowly. So mass being the universal constant, we can change the velocity, and the moment we are changing the velocity, that represent your acceleration, and mass into acceleration is what? That's your force. And we are also saying the same thing in the second law of motion. I hope that much is clear now. Now let me again explain this topic. Okay, let's revise the topic whatever we have done. So we have learned about the momentum. In the momentum we have learned it's the mass into velocity. The velocity here is constant. And what does the second law says? It says the rate of change in momentum is directly proportional to the force. Right? That's what it says. Now let's try to derive this, because in the second law there is a derivation that we have to do. Now what does the derivation says? The derivation is very simple. From here we have to move here. Okay, that much we have to do. Okay, now let's start the derivation. The derivation, we will divide the derivation in two parts. The first part is change in momentum. So what is momentum? It's the mass into velocity. That is momentum. We know that the velocity is of the two kind. What are the velocities? Initial velocity represented by u and final velocity represented by v. What do you mean by initial velocity? We have started the car. We have started the car. So when we have just started anything, the initial speed is known as your initial velocity. And when you are applying the brake and you are stopping the car, that time we got the final velocity. I hope that much is clear. So what is initial velocity? When you have start something and you have started something and you are moving, right? Because we are talking about the velocity here. So when you are in a motion, you have started something. जब हमने गाड़ी में कार लगाई है, सॉरी हमने गाड़ी में कीज़ लगाई है and we have started the car right now. So when we have started the car, that is represented by the velocity initial. And when you are applying a brake and you are stopping the car, the moment you stop the car, that velocity is counted as a final velocity. Okay, so we are having the two velocity. Now learn this concept. Whenever something says change in something, for example anything, here we will take velocity because we are talking about velocity, right? Change in something is what? That you are subtracting the bigger term with the smaller term. That is your change in something. Here we are changing in velocity. So what we will do? We will subtract the final velocity with the initial velocity. That is your change in velocity. That much clear? So if I apply my change in momentum, what it will be? Mass final velocity minus mass initial velocity, right? Because we are changing in momentum. So momentum should be of two type, initial one and the final one. So we have subtracted them. That much is clear. Now moving on, the next part is rate. Change in momentum is done, mv minus mu. Now the next part is saying about the rate. Rate means what? Rate means you have to divide it with the time. In physics or in chemistry, whenever you get the rate, understand that you have to divide it with the time. So we will divide it with the time. That much is clear. Now next step is what? Here we got m, here we got m, and we know that m is what? M is universal constant. So we can take m as common. So let's say I am taking m as common. Wait a minute. I have taken m as common. Now what we are left with? We are left with v minus u upon time. That much is clear. Now you tell me, we have learned about the acceleration. What is acceleration? Acceleration is change in velocity with divided by the time. That much we have learned. If you are not aware about this term, you can check my previous two videos where I have detailed explanation of this. Now acceleration is change in velocity upon time, right? Now change in velocity is what? Final velocity minus initial velocity upon time. That portion is clear. Change in velocity, which means we have to subtract the final velocity with the initial velocity. That's why we are changing now. Changing is what? That how much you have changed your speed. Let's say I got 50 marks in my test 1, right? And in test 2 I got, let's say, 60 marks. So how much change is there? So there is 60 minus 50, 10 marks I have gained. So there is a change of 10 marks. If I am going to add a 10 more in the test 1, I will get 60. So there is a change of 10 marks. Got it? So that's why whenever we are saying change in velocity, we have to subtract it. So our acceleration comes as v minus u upon t. Now look here closely. Acceleration is what? It's a v minus u upon t. Now look here. There also we are getting v minus u upon t. See this part. We are also getting v minus u upon t, which means that at the place of v minus u upon t, I can put acceleration. by the formula I can put acceleration there, right? This place I can put acceleration. So my this thing become a m multiplied with the acceleration. Now from the force formula, what we know, that mass into acceleration is what? That's your force. So from there we got there, and that's what all about your second law of motion. I hope that much is understood by you, but if not, then I will like to explain the things again. Okay, but this time I'll be a little bit fast. Now I'm not going to explain everything in a detailed form. So the second law talks about the rate of change of momentum is directly proportional to force. In the second law, what we have to do, we have to derive the formula of the force from the momentum. That's what we have to do. So firstly, what we will do, we will write momentum formula, that is mass into velocity. Then we are going to change it. So next step is change in momentum. That is going to be mass final velocity subtract mass initial velocity. Now what is rate of change in rate of change in momentum? That is, you have to divide it with the time. So we are dividing it with the time. Now take m as a common, v minus u upon t, and we know that v minus u upon t is a, right? So multiplied with the a. So that means our momentum and force is equal, but there is only a change in velocity happens. Clear? I hope that this much is clear to you. There is no doubt right now. So that was all about your second law of motion, and we have cleared this much part. If somebody is asking me about its SI unit, so momentum SI unit is mass into velocity. Mass is what? Kg, and velocity is what? Meter per second. So that being the momentum SI unit. Clear? Now see here, this is the law of conservation of momentum. What does it represent? It represents that, see, firstly the most important thing is conservation. I'm really sorry. Conservation. Okay, conservation. What does the conservation says? It says that we cannot create a new thing. We neither create nor destroy any new thing, but we can transfer it from a one object to the another object. And that's what this law also says. Whenever in physics, I will give you a trick to remember the law of conservation. The law of conservation represent that the thing, whatever the thing is, neither can be created, nor destroy, but transfer from one object to another. Now here we are talking about the momentum, so I will write momentum can neither be created nor be destroyed. If the same thing comes with the mass, so we will write mass can neither be created. If the same thing comes with energy, we will write here energy. So law of conservation is going to be the same. It says that we can neither create nor destroy the thing, but we can transfer it from one object to another. Okay, and if it's saying momentum, write momentum. If it's saying mass, write mass. If it's saying energy, write energy. That much is clear. Now understand this law. The law says that neither can be created nor can be destroyed, but transfer from one object to another. What does it represent? Now let's try to understand it. Let's say I have ball. A first ball is in the rest position. This first ball is not moving at all. It's in the rest position. Okay. Now there is another ball. Now this ball is moving. This ball is moving, and this ball is moving and is going to hit this ball. Now this moving ball A is going to hit this ball. So what will happen when it will hit the ball B? the ball B will start moving, right? Whatever the energy or whatever the speed the ball A is having, with the same speed, if the ball A going to hit the ball B, the ball B also start moving with the same speed as the A. So what we did here, we transfer our momentum. Momentum is what? Mass in motion. So we have transfer our momentum from A to B ball, and now the B ball is also moving. Did you get this concept? That's why we are saying that we can neither create the momentum and we can neither destroy the momentum, but we can transfer it from the ball A to the ball B. And momentum is what? Momentum is your mass in motion. So your ball B is in motion, which means it has attained the motion. It has attained the momentum. And in the momentum, what velocity does it has? It has the same velocity as the ball A is having. I hope that much is clear. I hope that now you get what this law of conservation of momentum is exactly saying. Okay, so that's what all about your second law of motion. Now in this law of conservation of momentum, there are two things that we need to understand. There are always going to be two cases. Let's say there are two balls. Okay, this is ball A and this is ball B. So let's say that this ball is having mu as an, let's say mu1 as an initial velocity, and this ball B having mvu2, let's say, as an initial velocity, right? First case, this is the first scenario, the two balls having mu1 as a momentum and as mu2 as a momentum, the same mass, and the two balls are coming in the opposite direction to each other. Second time what will happen, they will hit each other, and in the third time they will start moving in the opposite direction as the previous one, right? This picture is clear. In the first case they are moving in the opposite direction to hit each other. Second time they have hit each other and now started moving apart from each other in the opposite direction. So initially they are having what? They are having the initial velocity represented by u1 and u2, and now they will move with the velocity v1 and v2 because this is going to be their final velocity, right? So if I have to write this statement in the law of conservation of momentum, what I will write? I will write that m u1 plus m v1 is equal to m u2 plus m v2. Now what does this line says? This line represents that whatever the speed both the balls having, after hitting back they are going to have the same speed, and that is what all about the law of conservation of momentum. Let's say this ball is coming with the 5 meter per second speed, square, let's put square, okay, and this ball is also no, we will not put square, this is going to be acceleration. Now we have to keep it with velocity. Velocity is what? Meter per second. Acceleration is what? Meter per second square. So we will use meter per second, okay, and this ball is also moving with 5 meter per second, or 6, let's say 6, right? Now after getting hit, this ball will move with the 6 and this ball will move with the 5 meter per second speed. Now why this is happening? Because they have transferred their momentum with each other. So now what will be the total? Earlier we are having 5, now we are having 6. Earlier we are having 6, now we are having 5. So 11 and 11 both are the same thing, and that represent your law of conservation of momentum. Don't confuse ki ma'am why this ball is not moving with 5, because that is not the case. The always case is going to be that what the law of conservation of momentum we did that this ball A going to transfer its speed to ball B, and now the ball B will move with the same speed as A. Let's say A is moving with 5 meter per second. So the moment it hit the ball B will also move with the 5 meter per second. Here what is happening, that the ball A is hit by the ball B, so it has transferred its 5 meter per second speed to ball B. That's why the ball B is moving with 5, and ball B 6 meter per second hit by the ball A and transferred its speed to ball A. That's why it is moving with 6. That's why we have come up with this solution. Okay, if they are not going to like if they are not sharing their speed, or if they are not transfer their speed, then what will happen? 5 plus 5 equals to 6 plus 6, which means 10 equals to 10, though they are not equal na. So this law become false. There is no use of this law. Okay, so to maintain the equilibrium or to maintain the law of conservation of energy, we have to explain it in that way, or this is also the explanation of this law. Okay, I hope that much is clear to you. Now the third law is very simple. Third law of motion says for every action there is equal and opposite reaction. If you are going to slap somebody, the somebody will also going to slap you in the same energy. Okay, so that is for every action there is equal and opposite reaction. I hope that much is clear. The example of this, when you have started swimming, so your hands move forward but the water moves backward. So your hands move forward in whatever the force, you will put your hand in the forward direction. With the same amount of force, the water will also move in the backward position and it will provide you speed. I hope that much is clear. Okay, so for every action there is equal and opposite reaction, and that is the only explanation of third law of motion. So by now we have completed all the three laws. I will going to explain three laws in a summarized manner. In the first law of motion, we understand about the term inertia. What is inertia? It is the state in which you are. So inertia of the two type, inertia of rest, inertia of motion. First law says an object will be stayed in the inertia of rest or inertia of motion unless we are not applying any kind of external force to it. The moment we applied the external force, it will going to change its inertia. The prime example is ball, and we know when we are going to kick, the ball will start move. Second law of motion says about the momentum. So what is momentum? Momentum is mass in velocity. And what is force? Force is mass with the acceleration. Acceleration is change in velocity. So what the second law of motion says? It says that whenever there is a rate of change in momentum happening, it's always going to directly proportional with the force. And we have also seen the derivation of it. A quick derivation if you want me to do, I will do it very quickly. So we know momentum is m into v. So the change in momentum is what? M final velocity minus m initial velocity. The rate of change in momentum is what? Divide with the time. So we are dividing with the time. Now take m as common, we are left with v minus u upon t, and we know acceleration is what? Acceleration is change in velocity upon time. So change in velocity is what? V minus u upon t, which means at the place of v minus u upon t, I can write a, and now this is my force. So that is all about your second law of motion. In the second law of motion, we also talk about the conservation of momentum. What do you mean by conservation of momentum? It says that momentum can neither be created nor be destroyed, but it can only transfer from the one object to another. And we have seen the example to say that this is a ball B which is in the rest position right now, and this is the ball A is coming with the 5 meter per second speed. The moment this ball will going to hit the ball B, it will also start moving with the same velocity. So we have transferred it. We have transferred the momentum. Momentum is what? Mass in moment, mass in velocity. So ball B is in velocity right now. It has the mass, so we will call it as a momentum, and the velocity is of the ball A. That's what all about your law of conservation of momentum. In the law of conservation of momentum, we have also learned about that there are two balls, the ball A and the ball B. Ball A is coming with 5 meter per second speed. Ball B is coming with 6 meter per second speed. They have hit each other and now they are moving in the opposite direction. The ball A will move with the 6 meter per second speed. ball B will move with the 5 meter per second speed, and that's represent your conservation of mass, sorry, conservation of momentum. Okay, now third law is says for every action there is going to be equal and opposite reaction. If you are going to slap somebody, the somebody will also going to slap you with the same force. The pressure, the force that you are putting in water while swimming, moving your hands in the forward direction, with the same thing the water will also give you thrust, or the water will also going to give you the force in the opposite direction. Okay, so that was pretty much about the three laws. Now let's see if we got any other examples. If we will get, we will try to understand those examples as well. Okay, see, this is the momentum. The cricket players slow down the rate of change of momentum by pulling their hands backward while catching a ball. So what we are doing, we are using the momentum here to slow down the, what we are doing to slow down the momentum of ball. Okay, now this momentum conservation, let's read this. The sum of momentum of two objects remain the same. 5 plus 6 will remain the same before and after the collision, provides that there is no unbalanced force acting on them. Clear? Now this is also clear with the definition. Let's see if we got any example. No, we didn't get any. This example, we get two example. The motion of the rocket is based on the law of action and reaction and the principle of conservation of linear momentum. Always remember, I told you in physics we are not only following the one law, there are multiple laws that applied on the same thing. The backward recoil motion of the bullet when fired from the gun is based on the law of action reaction and the principle of conservation of linear momentum. What happened when we are firing any bullet? The bullet move forward but your hands move backward. So this action and this is reaction. And why our hands move forward? So that we can balance out this momentum. We have to balance out this momentum now. So that's why our hands move backward. So in short, we can say that whenever there is law of conservation of momentum is happening, it means the third law is also happening there, that is action and reaction. Clear? That much is clear. For every action has a reaction, we have already done it, going to be opposite and equal. Got it? Let's see if we got any example of it. No, we don't have the example of it. So that's pretty much about your three laws. I hope that much is clear. If it's not clear, you can drop the comment. I will check the comment and I'm going to explain everything in detail again. So whatever the topic that you are having any kind of confusion right now, you can drop the comment in the chat box and I'm going to read it and I'm going to explain that topic to you. Okay, now about the numericals, I will take the numericals separately. Okay, but before that I want you to cover the theory, because theory is very important for us to understand. I hope that all the three laws are clear. Try to revise them and I'm gonna come back again and I'm going to explain the further parts of it, and also we will try to solve some numericals. Okay, so yeah, if you like the video, please like, share and subscribe, and you can drop the comments and what the next topic that you want to cover. Please also drop the name of the chapter. I'm going to explain that one also. Thank you.